So the goal now is to be less generic and talk about how Python specifically implements object-oriented programming. So let's look at an example class in Python. So I want to highlight some parts. So this is a class definition. The class definition will always involve the keyword class and then some name for the class. So this is the name of the class. And notice that unlike function definitions, or functions or variables, the name of a class should always use camel case. So this syntax where no underscore is used, but all the words are capitalized. Now, my class here refers to two other classes called another class and yet another class that it is kind of dependent on. So this is called inheritance, and I'll delay discussion of this to next week. So if you don't want to use inheritance, and you shouldn't use it to start with, instead of those things here, you should just have object, which is, if you want, the most standard class that all the other classes should inherit from. Okay, so, and then there's a colon, so kind of like function definitions. Then there is a docstring, and this docstring follows the same convention as for function definitions. This means a little short first line, and then a space or a new line, and then a longer explanation of what this class does, and then another new line. And it uses triple quotes. Okay, so notice that this is indented. So this whole thing here is indented compared to this line that was the start of class. Okay, so it's indented by 2, 3, 4 characters. I took 2 here because it's on a slide. Okay, and then what follows is a bunch of function definitions within the body of that class. So here you see I've defined 3 different functions. So this is def, and then the name of the function, then some arguments, a colon, and then some action. Okay, so let's look at let's ignore this part for a few seconds. So let's look at here. So this here is just the definition of a method or a function associated to a class that I called first method. And this takes several arguments. So self, then some positional arguments, then some keyword arguments. And then it has a body, which is indented again and executes some other statements. Now, so you should know about all this, except for one thing, which is here, self. So it's important to understand that self is just another argument to this method, and it's just a convention that it's called self. So if you wanted, you could call it selfie or whatever you want, as long as you're consistent when defining this object. So we'll see this a bit later. But what's the purpose of self? Well, you will see it in a second for the definition of the second method. So the second method takes also as argument self and then some positional and some keyword arguments. We have decided to define a docstring for this method, unlike for first method. And then you see here what is going on with self. So why do you pass self as an argument? Because this allows you to use that object. So use the object itself to access some attributes of that object. So here, some attribute is a data attribute of self, and I actually use some other function, do that, or I compute some other expression that I bind to self.some attribute. Okay, so that's the general way you define a class. You write class, and then in the body of the class you give different function attributes, so different method attributes, different methods that you define, and within that you are allowed to use data attributes as well. So like this one. Okay, this is all good, but I didn't talk about init. So what does init do? Well, init is what's called a constructor. So the principle of init is similar to what you would do when you initialize an imperative program by defining some variables that you will need and so on. So this is what is done here. I just use the data attribute, some attribute of self, and I assign some value to it. And maybe some values defined based on the arguments that are passed to the constructor. So init is a constructor, and it realizes instantiations of classes. It creates objects of the type myClass. Okay, so that's important. It creates new objects of that type. Okay, so this was for the very generic introduction to object-oriented programming in Python, and we'll now start looking at a few examples.